Well, this is John Black, super chemist. We're going to make some propene today. That's double bond hydrocarbon. As you can see at my apparatus there, I got a test tube there on the left, and there's isopropyl alcohol in there, rubbing alcohol. It's only like 70%. On the top there, I got some cotton, and on top of the cotton, I threw just a little smidge of aluminum oxide. That's an abrasive. You use it in sandblasting, or I used it for a refractory material because I was making a foundry. But I have some left over, so I threw some in there. You can see I'm trying to keep, you should keep the heat on the top part there where the catalyst is, and very little onto the liquid. Um, you can't have the catalyst fall into the liquid, and that's what the cotton is there for. If you watch, I'm making a lot of, I'm doing this too much on the, you can see I'm boiling away the liquid too much, the isopropyl alcohol. And see right there, it's a good propene mix. But as I go, if you redo this and rewatch it, you'll see that some of the liquid is, see there how it's kind of vaporous. So it is catching some of the alcohol on fire. Um, Now to prove that I am making propene and not just distilling off isopropyl alcohol and uh, catching it on fire, I have another apparatus here on the right. Same thing. Got the isopropyl alcohol on the bottom, cotton to hold the catalyst. Throw a little catalyst on the top there. Have my tube leads to an inverted test tube, and that test tube is filled up with water. And I left a little bit of air on top just so you can see that it's not just an empty tube. See, there's actually water all the way up to the top, tippy top there. And I'm basically going to do the same thing there here, but this time I'm not going to catch the gas on fire. I'm just going to collect it so you can see. Now, if this was isopropyl alcohol, it would just go into solution, right? Because alcohol is soluble in water. But propene is a double bond, so it is not soluble in uh, water. It's a hydrocarbon. Ain't going to be soluble. When you do this, you should always put 95% of your heat on the catalyst. The alcohol itself will boil off just because the heat will transfer through the glass. You don't really need that much, and that way you can, instead of making, like I said, vaporous isopropyl alcohol, you'll just be making the propene. And you can always use a scrubber or something to get get the alcohol out. I want to fill that test tube all the way up until it hits the bottom. Now this reaction, I'm not sure about the. I tried looking it up online. The only thing I can find is that it works. I don't know the name of the reaction, so it's tough to look it up. If anyone knows the name of the reaction, please post and tell me what it is. Maybe I can look it up. I'm not sure if it's. I think it's just a catalyst, but who knows? I'll go over that in a minute here. And here we'll see if it's flammable. You can see it's just a little bit flammable. Like I said, I'm not sure about the mechanism or whatever, but if you look up here to the left, and I haven't taken crystal field theory or Ligand field theory or whatever, but I'm just, so I don't know if that's exactly how to write the molecule, but the formula is definitely aluminum 2, oxygen 3. So I wrote it up there. If that's the way it is, you can see there is a ring there, a three-sided ring. That's a lot of stress. I'm sure that wants to open up. I'm sure that wants to react with stuff. If it is reacting, it's going to, as the only stoichiometry I can get out of it is what you see there, which would be 3 propenes and 2 aluminum hydroxides. You can see how they would split up there to be 2 aluminum hydroxides. But if it's just a catalyst, it would be the next formula there, and that's basically the catalyst is not changed in any way. So it's just in the middle there. You just have three, or actually, I should have changed that to one molecule per one propene, one alcohol per one propene. And then I want you to see down there at the bottom, the two aluminums. I split that up. See up on top there how there's two aluminums? I got two aluminums. And then they're surrounded by three oxygens. I only let one of them be surrounded by oxygens so you can see what I'm talking about here. I hope you can see how they changed. The one has three hydrogens, and the aluminum to the right now has three OH groups. If you combine those, obviously you have three H2O groups, three water groups. Whether they get attached to the aluminum oxide and react, you know what I mean, or not. And if not, that means that you're producing. I should have actually put water up on there. Let me fix that. If it's just a catalyst, you're going to actually produce water. If that water isn't put onto the aluminum, making aluminum hydroxide, then it's got to be put somewhere. And it's obviously going to be put into actual water, liquid water. Which one it is, I don't know. I'm hoping this causes some kind of discussion. Maybe someone will get on and talk about it. But I do want y'all to remember science is great.